One of the key divisions of the main sponsor of this conference, Black Cell, is Cybersecurity Operations Center as a Service. So it is with special excitement that I'm pleased to welcome Mr. Milan Pikula to our SecOps conference. Mr. Pikula is Technical Director of IT Security Consulting. More importantly, he is a cybersecurity consultant at the Slovakian CSIRT, managed by the Slovakian National Security Authority. Please join me in welcoming our next speaker, Mr. Pikula.
National Security Authority runs or have been running NATO-level CSIRT since 2011. We were producing bulletins and advisories and so on, and as some of you already heard on the previous presentations, with the upcoming legislation according to NIS directive, we are transforming ourselves to the national level CERT, and that comes with a whole lot of other responsibilities. We are already creating some products, some advisories, we are doing event and incident handling, also coordination, audits, malware analysis, forensic analysis, and we are all the time trying to build up our capabilities by attending trainings, by contributing to open source, stuff like this. And we realized we need a different set of software and hardware to be able to do what we need to do at the national level. And we started with the goal. The goal was to achieve the best possible security for our constituency, meaning we have to learn and inform about threats and vulnerabilities. We have to identify and be able to successfully handle incidents. We have to be able to perform security audits and so on and so on. But of course, there are always constraints. So let's make it work without spending a fortune on the hardware and software, and let's do it in the most automated way so that we don't waste time and precious human resources. Who am I kidding? Actually, we haven't started the goal, but with a cool room. This is how our monitoring room looks like. And let's go back to the theory. So, what do we wanted to be able to monitor? We were trying to achieve multiple different goals. To be able to monitor threats and vulnerabilities, which is usually a CSIRT role. To be able to monitor events and incidents, which is usually SOC role. And also to be able to do a bit of NOC operations. There are various kinds of software you can use, open source existing software you can use for this, and this is our story, how we put it all together and made it work. So let's start with the simplest, the NOC. So we are monitoring web pages, servers, hardware, business logic. By hardware I mean everything, the firewalls, routers, switches, servers, storages, PDUs, AC, air conditions, and fire alarms, everything there is. And there is a great open source software named Zabbix, which we use. Of course, it's quite hard to use it on large scale. That's why the architecture supports Zabbix proxy servers, which you put into various environments, and then you use one central Zabbix server where all the information is aggregated and stored. Many such devices are able to send out syslogs. We have log aggregators on various places of the networks that we monitor, and it all ends up in the Elasticsearch and Kibana. So the operator is essentially using two web interfaces. One of them is the Zabbix interface, and the other one is Elastic interface. What they do with it? They are using trouble ticket management system and some knowledge base, and of course they are doing some bit of communication. So in order to be able to quickly create a new ticket from the results of Elasticsearch, from what is displayed in Kibana, we made a small graphical user interface page which allows us to move specific lines of the search results directly into a ticket. We are using track software for ticketing and knowledge base, which is very convenient because you can reference wiki pages from the tickets and vice versa. We are using the existing infrastructure in the track, which allows you to communicate using email with various external components. And on top of it, we build connectors for some other external ticketing systems that are in use by our partners. So let's go to the more interesting part, which is a SOC. So what do we monitor here? We are monitoring the outputs of the various IPS systems, such as Snort or vendors like Cisco, Checkpoint, Palo Alto, FortiGate. We are monitoring the outputs of the web application firewalls, email appliances, web proxies. We are monitoring net flows. We are monitoring application level hours from servers, which I will detail very soon. And also there are some indicators of compromise that we receive. So how we do it? First of all, events and incidents. Many existing devices send information using syslog, using SNMP traps, and so on and so on and so on. There is plenty of existing open source that you can use as a CM software. We chose OSSIM. Into the OSSIM we are receiving the events from these sensors. We created multiple input plugins for them. We are parsing syslog that, as I previously mentioned, is collecting from all the machines throughout the network. And maybe you know the open source software named fail2ban. You can install it usually on the servers, and it will check the logs for traces of, for instance, password cracking attempts, stuff like this. We are doing the same, but we are reusing the signatures from the fail2ban and matching them against all the syslogs that are entering our central syslog monitoring. That means on any of these machines, if someone tries to guess the passwords or whatever else, we have it covered. Also, we have host firewalls installed on many machines throughout the network. Some of the rules, as some of you who already configured firewalls may know, some of the rules that deny some traffic are triggered quite often. You cannot display that a certain packet was blocked on the CM software. It would make no sense. But in certain circumstances, for instance, if you have a separate network where only servers are located and you know exactly what are the allowed kinds of communication, on such networks you can create a firewall rule that will log the connections outside of the allowed ports and protocols. And we are logging this into the syslog with a specific prefix that we are matching again in the syslog part of the solution. And whenever such event occurs, we display it as the incident in the CM software. That means when someone successfully breaches our defenses and they will gain access to some of the internal servers, and they are the first thing you do, you scan the neighboring machines to get more access to do some lateral movement. And this is the time when we are able to detect them and do some proper incident response. The same goes for the Linux-based kernel hardening products such as AppArmor and SV Linux. All the breaches of these policies are immediately detected from the syslog and displayed in the CM software. Then you have many sources of IOCs, indicators of compromise, which we match. I will detail this on the next slide. Which we match against the net flows that we collect. So we are using various kinds of software to receive IOCs. Actually, it should not say Intel MQ and Taranis. It should say Intel MQ and MISP. That's a typo on my slide. I'm sorry. But when IOC is received, it's matched against the latest connections detected in our network, and immediately if there is a match, then it means we have been communicating with someone who is on some blacklist, and that is also displayed on the CM software. So such feeds go to Elastic, but they are matched against the net flows and vice versa. The new flows are checked against the latest IOCs, and the matches are displayed in the CM software. So what do we do with the outputs of the CM software? Again, there is some operator who is using the CM software. The operator is using two web interfaces. One of them is the OSIM, the other one is Elasticsearch and Kibana. To make the workflow seamless and easy and fast, we made several alterations to the graphical user interface of these three systems, OSIM, Kibana, and Track. We added possibility in the OSIM to create with a one click a trouble ticket from the event. Also, we made it possible to search for the IP address of the event in the Elasticsearch for the Kibana web interface. And again, which I already mentioned in the node part, when Kibana displays some search results, we can put them into the tickets as well. So it's very easy, no need for copy and paste, and of course all the rest of the flow, the communication with external parties, usage of the track for ticketing, using of the track for wiki and knowledge base applies. The last part are threats and vulnerabilities. That means learning about what is hot, what's going on in the world, not necessarily in our own network. So for this, there is an excellent piece of software named Taranis, which is able to receive feeds from multiple sources, correlate them, and create even advisories and automatically send them out. At this moment, we are not using this software to its fullest. We are using the first half of it, the part that receives the information, that is able to combine them, and the analytics part. We are currently creating advisories on our own using a regular text editor. There is a to-do here in the red to implement automatic sending of the nice advisories based on the template from the output of Taranis. Of course, at present, these advisories are not very customized based on the recipient. We are issuing out warnings about mostly anything that matches certain threshold. In the future, we would like to send advisories specifically to the parties that are affected. To this end, we need to have a list of assets, list of software, hardware, which is being used by our constituency. So we are planning to collect this information automatically or semi-automatically by using, for instance, OpenVAS, which is able to do not only vulnerability scanning, but also it can identify the versions of the software that is reachable on the network and put it out in the CPE format. And we are planning to match these CPEs against the reports that we are sending out, and we will be able to send a specific message, hey, we know you are using, for instance, Apache such and such version, and there is a vulnerability in it, please upgrade. Of course, the communication component is reused. And finally, this is what I've been talking about when you zoom out. It looks horrible, but believe me, it's very convenient to use. And so, okay, what I was not talking about is a human factor. We also need to have some policies. We have policies for event and incident handling, threat monitoring, security audits, and other important areas. And all these policies are available in the wiki, in the track system, which I mentioned already. The top level policies we have in a graphical format, which is a work of my colleague. I like it very much. And all the details are present as wiki pages with detailed tutorials for the handlers, for the operators who don't know how to do their job. Missing from the picture are parts such as system administration, infrastructure, L3 activities, and so on, which are not exactly scope of this presentation because there are tools for all of these areas which are very common, easy to use, and so on. So I don't feel it's important to share our experience with them. The last part of my presentation is a recap of the maybe most important pieces of software that we use. For CVEs, for vulnerabilities, there is Taranis. For indicators of compromise, it's MISP and Intel and Q. For CM, we used OSINT, there are other products, and Zabbix. For visualization of data, Elasticsearch and Kibana. Ticketing, knowledge base, there are many systems that can do this. We used Track, I forgot to mention. We used the very nice feature of the Track that you can customize the workflow, meaning we modeled the exact process of the incident handling in the ticketing system. So the life cycle of the ticket follows what the incident handlers do. And for sensors, you can use anything you want, but if you want to use open source and free software, there is, for instance, Snort and Suricata. There is the web application firewall named Varnish, which has a nice set of rules named VSF Varnish Security Firewall, available on GitHub, which we also use for web application firewalls. And of course, there is generic software such as syslog, host-based firewall, stuff like this. And for virtualization, for most of the software that we run, we again use free and open source solutions such as KVM in the Linux kernel. So that's essentially it, and of course it also requires time, lots and lots of doing to make it work. Thank you. I've been told that you can put some questions online, so let me check if I'm able to reach them. Oh, there is one. Are you using described solution in SecCert? What is the scale of monitored systems, number of devices, amount of logs per day? So for the first part of the question, I can answer yes, we are using this. Regarding the scale, we have the same system deployed at two places. One of them is the government network named GovNet, which connects ministries and some other important organizations. At this level, we are collecting huge amounts of logs. I don't know, unfortunately, the exact numbers. I was trying to get them for my presentation, but it was not successful. But only for instance, the Zabbix part, I know for sure that about 900 new values are inserted into database every second. Regarding how much gigabytes of the logs we collect every day, I'm not sure about that, but it's a lot. We have a huge storage beneath it. On the national level, within SecCert, we are only beginning, so the amount of data is not that big, but we are prepared to scale it. And most of the software that I mentioned, for instance, the Elasticsearch, is very scalable in this regard. Okay.